Find the line that passes through the point of intersection of the lines y equals 1/3 x minus 2 and y equals half x plus 3, whose gradient is -3. Okay, the first thing is to find the point of intersection of these two lines here. Okay, like we saw in the other video, point of intersection is simply gotten by solving the two equations of the lines simultaneously. If we call the first line equation 1 and the second line as equation 2. Okay, we want to solve this algebraically. If these two lines intersect, then at the point of intersection, there is perfect agreement between the two lines. Or at the point of intersection, the two lines are equal. All right, the left-hand sides are equal, so we just simply equate the right-hand sides and solve. So at the point of intersection, at the point of intersection, the two equations are equal. The two equations are equal. The two equations are equal. Okay, so we just equate the right hand sides and solve for x to get the x coordinates of the point of intersection. And so we do that equality. Now we'll bring the like terms together, x terms together, and the constant terms together. So we have 1/3 x minus a half x is equal to 3 plus 2. What have I done? I've taken -2 to the right hand side, it becomes +2, and I've taken a half x, which was positive here, to the left hand side, it becomes negative half x. So that here our LCM is 6. 6 divided by 3 is 2. 2 multiplied to x is 2x. 6 divided by 2 is 3. 3 multiplied to x over there is 3x. That gives us 5 here. So we have negative x, 2x minus 3x is negative x all over 6 is equal to 5. 5 all over 1, so we carry out cross multiplication. So we have negative x is equal to 6 multiplied to 5 is 30, which therefore means that x should be -30 when we multiply both sides by negative sign. So here we have the x coordinate of the point of intersection of those two lines. To get the y coordinate, it's simple. The y coordinate is simply gotten by replacing this value of x in any of the two equations. All right, if we take equation 1, all right, if we take equation 1, we just simply put the value of x to be -3 in equation 1. That will give us the y coordinate. Y will therefore be 1/3 into -3 minus 2. So you see negative cancels there, it becomes -1 minus 2, which is simply -3. So the y coordinate of the point of intersection is -3. So the coordinate of point of intersection is -3, -3. All right. So the line that we're looking for passes through the point -3, -3, and has gradient -3. How do we get that line? That's the next part of the work. We now get the line. Okay. So required line. Our required line passes through the point -3, -3, and has gradient -3. All right. So if we call this point x0, y0, for example, all right, now that equation will be given by y minus y0 is equal to the gradient into x minus x0. So y minus y0 is -3 is equal to our gradient is negative 3 into x minus x0 is negative 3. So we have y minus minus become plus. Negative 3 into x minus minus become plus. So we have y plus 3 is equal to, open out that bracket, negative 3 times x, negative 3x, negative 3 times positive 3 is negative 9. All right, we can leave it as such, but no, we can't leave it. We put it in the standard form, so that we should have y alone on one side. This is positive 3, take it over, it becomes negative 3. So you have negative 3x minus 9 minus 3. So that you have y is equal to negative 3x. Negative 9 minus 3 is negative 12. So this is the equation of the required line.